Assalamu alaikum guys, welcome back. Okay, so now in this video we are going to talk about metallic bonding. In the previous video we completed ionic bonding. Now metallic bonding. Okay, metallic bonding is actually found in metals. Okay, metals you must have, and it's exactly almost the same as the one which you have done in your O levels. It's found in metals. What are metals? Metals are basically found in group 1, group 2 transition metals, and somewhat in group 3 as well. So basically group 13, I should rather say now, because it's A levels. Now this diagram must be familiar, right? You must have seen this in your O levels as well. What is the structure of a metal? First of all, let's look at the structure inside a metal. Metal is composed of two things. First of all, it is composed of ions, and secondly it is composed of electrons. Okay, so if you were to define metallic bonding, first of all, let's define a metal structure. So a structure of metal is actually made up of positive metal ions surrounded by a sea of delocalized electrons. Okay, I should just write this down. Positive metal ions surrounded by a sea of delocalized. Now this delocalized term is your key term. Sea of delocalized electrons. Okay, because electrons are can be localized as well, but localized electrons will not give you metallic characteristics. Okay, so this is a very the unique property of metals, that they contain delocalized electrons, due to which they are able to conduct electricity. And similar to metals, remember we did graphite. Graphite also contains delocalized electrons, due to which it was able to conduct electricity. Similarly, graphene, which was an allotrope of carbon, also contained electrons, delocalized electrons, due to which it was able to conduct electricity. Similarly, ionic compounds in molten state or aqueous state are able to conduct electricity. And if they are in the solid state, they won't be able to conduct electricity, because the ions are not going to be free to move. In that case, it's the ions that conduct the electricity. Okay. Now let's define metallic bonding. So metallic bonds are actually electrostatic forces of attraction as well. These are also electrostatic. This is a key term that you must use. Electrostatic forces of attraction between positive metal ions and the sea of delocalized electrons. Delocalized electrons. Now this is the complete definition of metallic bonds. Okay, what are metallic bonds? Metallic bonds are actually the electrostatic forces of attraction between the positive metal ions, which you can see over here, these big balls. These are the metal atoms or the metal ions, which are actually surrounded by the sea of delocalized electrons. Clear? Now this was the definition of electrostatic forces of attraction or metallic bonds. This diagram is very important for you guys, because the examiner asks you to draw out this diagram. Okay, to draw the structure of metals, or to draw the structure, the metallic bonding, etc. This is what you are supposed to draw. You have to draw at least 3 columns, 3 rows and at least 4 columns. Okay, this is the minimum requirement that you must draw. You can add in an extra layer as well, of another layer of 4 atoms in here, but this is the minimum. If someone draws only 2 layers, only 1 layer, it won't be acceptable. Okay, that's the latest marking scheme that I'm telling you. Then coming to alloys. What are alloys? Alloys are basically mixtures of 2 or more metals. As you guys know from your O levels, the alloy is a mixture of 2 or more metals. Okay, 2 or more metals. Okay, and a common example is bronze. You must have studied bronze in your O levels as well. Bronze is an alloy of copper and tin, right? And brass is also an alloy, which is an alloy of copper and zinc. Okay, and the structure of an alloy can also be asked to draw out. So you guys know from your O levels that alloys have irregular atoms inside of them, meaning atoms of different sizes representing different metal elements inside of them. Okay, if you are asked to explain or to give the reason why metals are able to conduct electricity, so it's the the delocalized electrons that move to conduct the electricity. Okay, where do these electrons come from? Are these all the electrons present in an atom? Basically, are these the electrons present in the innermost shell of an atom or in the outermost shell of an atom? So the answer is outermost shell of an atom. Okay, atoms, they donate their outermost electrons to the sea of delocalized electrons. Okay, outermost electrons are donated. So if I were to ask you a question that let's say we've got three metals, sodium, magnesium and aluminum, which of these elements would donate the most electrons to the sea of delocalized electrons? So the answer to that is going to be aluminum, because aluminum is in group 3, and since it's in group 3, it can donate 3 electrons per atom. Okay, 3 electrons per aluminum atom, meaning every aluminum atom will donate 3 electrons to this sea of delocalized electrons, whereas sodium only donates 1 electron to the sea of delocalized electron per sodium atom. Clear? So this brings us to the end. Okay, so you are asked to draw the structure of a metal, okay, which is important. You must know what these signs represent. These are positive ions. You must know the delocalized electrons. You must know this, that the metals are able to basically it's the outer shell electrons that are provided to the sea of delocalized electrons. You should know the definition of an alloy and the diagram of an alloy, which I have not drawn over here. Okay, and then last but not the least, what are the different properties of metals? Okay, so a basic question from your O levels, but I'll still revise it. Okay, so metals are malleable. What does malleable mean? Malleable means they can change shape without breaking. Metals are ductile. What does ductile mean? Ductile means they can be drawn into thin wires. Okay, you can see wires of metals, right? So yeah, they can be drawn into metal, so therefore they are called ductile. They are sonorous. Sonorous means when you hammer them, they can produce a ringing sound. And yes, of course, when you hammer a metal, you can hear a ringing sound. But if you hammer a non-metal, you might not hear a ringing sound. Okay, malleable, ductile, sonorous. They are shiny. They are good thermal and electrical conductors. Okay. Thermal and electrical conductors because of the delocalized electrons that are present inside of them, that can move around to conduct electricity as well as heat. And there's a second mechanism of transferring heat as well. These atoms that you can see over here, or the ions of these metals, they can vibrate around here and there around their fixed position to transfer the heat as well. Whereas the electrons can also move around from one place to the other to conduct the heat. Okay. So this brings us to the conclusion of metallic bonding, and this officially completes the chemical bonding chapter, alhamdulillah. And now we are gonna look at, from the next video, we are gonna look at redox reactions. Thank you.